Hello. Now after building two small applications and getting used to of Android Studio and how to create Android Studio projects, let's dig deeply into user interface. As you know that user interface is the most important component in your application and this will be the point at which the user will interact with your applications. Let us see how Android Studio and Android operating system allows us to create wonderful user interfaces for our applications. A user interface in an Android application is built using a hierarchy of view and view group objects. The view objects are simple UI widgets such as buttons, text fields, radio buttons, etc. While view group objects are the containers. These are the view containers that define how the child views are laid out, such as in a grid or a vertical list, and these are the containers of different other view objects. If you look at the image, we have a view group at the top. This view group has three elements, two view objects and one another view group, and which again has three elements of view of three different which again has three different view objects. This is a sample of a simple user interface. In our application we had also created a similar layout. We will study that when we open our application. Android also allows you to define UI in XML using a hierarchy of UI elements, as you saw. That we could directly manipulate the XML file and add some of these view objects and view group objects directly into our program without actually writing a code for them. So let's look at the view group. This is a simple definition of view group as given in the Android documentation. As you can see that view group is an abstract class. It extends view and implements two interfaces. This class is defined under java.lang.object to Android view and then Android view group. You can see more details about it by following this link. So a view group is a special view that contain other views which are called children. The view group is the base class for layouts and view containers. In our program, we have already used a layout called LinearLayout. And this class also defines the different view group layout parameters, which serves as the base class for layout parameters. We will be studying them in detail. Some direct subclasses of view group are LinearLayout, RelativeLayout, and many others. You can get the full information about the subclasses by following this link. Now let's come to the layout. When we started our program started with a simple placement of certain view objects. If you remember, then in our first application we had a hello world string at the top and nothing else. And then slowly we removed that hello world string and we added another text field. In our second applications of math quiz, we actually added a text field which was displaying the question, and then we added two buttons. Now let us see how that is organized inside an Android application. So layouts define the visual structure for a user interface, such as the UI for an activity or an app widget. We can declare these UI elements in XML, or we can instantiate layout elements at runtime. However, declaring these UI elements in XML is a better approach because it allows a separation of the code and the presentation. You can keep the .java files only for writing a logic and .xml file for the presentation, so that when you have to make a change in the presentation, you do not have to change the code. Different types of layouts are available in current Android app environment. These are mainly linear layout, relative layout, list view, and grid view. Let's start with the linear layout. So linear layout is a view group that aligns all children in a single direction, either vertically or horizontally. You can specify this direction by using the attribute called Android orientation. As you see in this example, here 1, 2, 3 are defined horizontally. Similarly, I could have defined them vertically. Here on the left side we see a sample XML file, and on the right side we will try to see each individual element as it appears in the XML file. So let's start with this. As you see, the first line of the XML file gives nothing more than the XML version and the encoding used. And then the second line, the very first line, XML-NS, which stands for XML namespace Android, gives the location of the schema where the first line starting with XML-NS Android gives the location where we can find this XML schema. If you do not know about XML, it may be a good time to read about XML and XML schemas from internet resources. Now, let's start here. The first two elements that we find are Android layout width and Android layout height, and both are assigned to a value called match parent. Let us see what these are. So Android layout width and Android layout height, they refer to the width and height of the layout as you could have imagined. And these can be given following values. One of the value could be match parent. Match parent means that this view wants to be as big as its parent minus the padding. Another value could be wrap content, which means that this view just want to be big enough to contain its internal content, and this takes into account the padding. And the third could be that just an integer which gives the fixed size for this in terms of pixels. As you may have guessed that match parent and wrap content are also defined as integers. Now the second element is padding. As you know that padding refers to the space that is available on the sides. So padding left and padding right refers to the empty space that is available on the left and the right, so that your element does not look very much touching the boundaries. So for example, if I am displaying a text, I do not want to see that my text is touching the boundaries on the both sides, and I usually like the view when there is some empty space in between. This empty space is defined by the padding left and padding right attributes. Most often you will see padding left or padding right with something like this, 16 dp. Here the number is a floating point number and it is then appended with the unit. We have different units available to describe the padding size. For example, px stands for pixels. dp stands for density independent pixels. We may also have sp, which means scaled pixels based on preferred font size, and then we can have inches and millimeters. The next element then is the orientation, which we have already discussed. It could be either vertical or horizontal. Then we may sometimes also have something called weight. As you see that in the following XML, we have the weight here. The weight is supported by the linear layout and it assigns an importance value to a view in terms of how much space it should occupy. So a larger value for weight will allow the particular view object to expand to fill any remaining space. So if I am giving a higher weight to one of the view objects compared to other view objects, then that particular view objects will then expand to occupy more space. Gravity. Let us see. So we have the gravity element here, which says it top, and here the gravity says right. So we are defining gravity at two places. So gravity is used for placing an object within a potentially larger container. So think of it as a placeholder. So if you define it as bottom, then your view object goes to the bottom. If you define it as a center, your view object goes to the center. If you define it left, it goes to the left. If you define it top, it goes to the top. And then we have Android hint as given here. Hint is simply a hint text which needs to be displayed when the original text such as this is empty. And Android text is the text which will be displayed. However, if it is empty, then the hint will be displayed. So now if you go through the XML file again, we have described every field that is appearing. So far we have not described what is edit text and what is button. These will be described in a short. So far we have not described what is edit text and what is button. We will soon be describing them as well. But as you may have guessed, edit text is a placeholder for a text and button is simply a button as we added in our application last time. The another layout other than the linear layout is the relative layout. If you remember, when you created your application directly from the Android Studio, then the initial XML had the relative layout, which we later deleted and we created a linear layout for our application. So what is relative layout? Relative layout is similar to linear layout. However, it displays child views in relative positions. So you describe view elements relative to each other. So for example, the position of each view will be specified as relative to its sibling elements and relative to the parent area. So from parent area you can say, oh, it is in the bottom or in the left or in the center. And then from sibling elements you can also describe that it is left of a sibling element or below a sibling element. Let us see a sample XML that uses relative layout. Here is the example of the XML that is using relative layout. We will not go through each of the fields because we have already described them. We will only go to the fields which are newer than the last slide. We will only go to the fields which are new compared to the last slide. So let us look at something called Android Layout Align Parent Top or Align Parent Left or Align Parent Right. What it means is that with respect to the parent, if it is true, then it will go into the left of the parent. If it is true, then it will go into the right of the parent. So, for example, layout align parent top, if true, makes the top edge of this view match the top edge of the parent. Similarly, if layout is center vertical, if it is true, then it centers this child vertically within its parent. If the layout below, then it positions the top edge, of this view below the view specified with the resource ID. And if it is layout to right of, it positions the left edge of this view to the right of the view specified with the resource ID. Now, what is the resource ID that we are referring to? As you see that for this element, I have given a resource ID of @id times. And then in the button, I am describing that it is layout below to whom? @id times, which means that this button will be below than the spinner. So that's how we define elements in a relative layout. Now you may understand that why we change the relative layout to the linear layout when we started our simple applications. Because in our applications we were only displaying a text field and two buttons which could be more easily described in a linear layout. Depending on your application requirement, you choose either a linear layout or a relative layout. More details about relative layout can be found on this link. The other two layouts are ListView and GridView. These layouts are separate from the previous two layouts. And these layouts are useful when the content for your layout is dynamic or it is not predetermined. So list view and grid view layout allows you to populate the layout with views at runtime. That is, you can add elements into it. So these list items are automatically inserted to the list using an adapter. We will learn about the adapter later on, but as you may imagine, suppose I am going through a list and I want to add the view elements by reading that list. In those cases, list view or grid view layouts are more suited to my application. Now, after the layouts, let us understand the input controls a little bit. Now, let us first see the application that we have developed and see how we have defined the layouts in those applications. So I am opening my math quiz application. I will go to my activityquiz.xml file, click, and as you can see, we are describing a text field and we are describing two buttons. So let us go to the text file. So in this, we started with the linear layout. We described the layout, linear layout, to be of the width of match parent and height of the match parent. And the gravity was described as a center. Because the width and height are match parents and the gravity is center with an orientation vertical, the layout will cover the screen completely. Then we described a text view where we described its width and height to be wrap content. That is just enough to have the element inside it, this string, with a padding of 24 dp. Now let us see how it looks in the design. As you can see that this is the box. The box is just big enough to contain the string, and then there is padding space of 24 dp on each side. After that, we describe another layout, another linear layout, and in that linear layout we describe two buttons. So essentially we are actually describing another linear layout here, and in that linear layout we are describing these two buttons. And the way we are doing it is that we want that linear layout to be just large enough to contain the objects that are within, which means the two buttons, and we want them to be in orientation horizontal. That is, we want the buttons to come from left to right and not from top to bottom. Had we described the layout to be vertical, the buttons would change their position. Let us see that in action. Let me change it to vertical. Save it. And as you can see that the orientation is changed. Let me change it back. Now for these buttons I am describing an ID, and I want the button to be just large enough to contain the content, which is the true, and same thing for the another button, to just large enough to contain the text fonts, and that's what you see here. I end the linear layout, inner one, and then the outer one. So this is all about layouts and some of the view objects such as the text field and the buttons. Now let's go back to our lecture and learn more about input controls. As you saw that in the previous example, we were giving our input by pressing the buttons. Similarly, there are other controls available such as text fields, seek bars, checkboxes, zoom buttons, toggle buttons, etc. etc. You may know about all of these controls on Android developer documentation. So input controls are the interactive components in your app's user interface. These are the components by which a user interacts with your application. And just like the layouts, you can also add the input control by just modifying the XML file. Here is a sample version of it. As you can see that we are giving a button here, and the button has an on click enabled. This code means that when this button is pressed, to send message function is called. And on top of this button, there is an edit text, which reads out a message that is defined in the resource edit message. Now, Android applications use what is called event-driven programming. In event-driven programming, usually once you start the program, your program waits for an event to happen. In this case, the event could be pressing of a button, or the event could be Android applications follow what is called event-driven programming, just as any other UI applications. Event-driven programming requires the user to act, and based on that action, an event is generated. For example, when user presses a button, an event is generated. If there is a checkbox and user selects the checkbox, another event is generated. And then these events are captured and a callback method is called. This callback method then defines the process flow. If you don't know about event-driven programming, maybe you should read about it separately. Essentially, whenever you will do an action, a certain method in your program will be called, and that method will define your process flow. So for example, we have a view object with which a user interacts. The callback method associated with that view object will be called and will define the process flow. So our view class provides a collection of interfaces called event listeners. Each of them has its own callback, which is then called when that interface is used for user interaction. So event listeners is an interface in the view class that contains a single callback method. These methods are called by Android framework when the view to which the listener has been registered is triggered by user interaction with the item in the UI. If you remember, in our math quiz application, after we had added the buttons, we added an on-click listener to it. That was our way of associating the event listener with the click event of the button. More detail about event listeners can be found by following this link. Now, let us look at some of the UI elements that we have used in our programs. Buttons. You may have interacted with buttons already because they are so prevalent in all the Android applications that have been developed and in any other UI application. So in Android, a button consists of a text or an icon or both, and that communicates what action occurs when the user touches it. You may define the action that takes place when the user clicks a button. There are two ways in which a button responds to click events. Number one, in the XML itself. For example, here you can define the message, and then later on you can give the complete definition of the message on what happens when the on-click event happens. This is one way of registering an on-click event with a button. Another way is to use an on-click listener. This is what we did in our program. So we have a button. On that button we attach a listener. That listener then uses the callback method, in which we define the functionality that happens when the user clicks that button. The other UI elements that we are using in our program is text field. Text fields are used for displaying text to the user. Optionally, you may allow the user to edit it. So text field as such is a complete text editor. However, the basic class is configured to not allow editing. A special subclass called edit text configures the text view for editing. So in our application, we added only a text view which was only displaying the message is 19 a prime number. However, if you want the user to edit it, you may choose instead of text view an edit text, as we saw in the XML file of this lecture. We can set the XML attribute Android text is selectable, which then allows user to copy some or all of the text view's value and paste it somewhere else. You may also call set text is selectable true. More information about text view is available by following the link given here in the slide. The last thing that we used in our program were toast. This was the correct or incorrect message that was popping up when we were pressing true or false button. So toast are used for providing simple feedback about an operation in a small pop-up. Toast only fills the amount of space required for the message and the current activity remains visible and interactive. For example, when you move from your email application, normally you get a pop-up which says draft saved. That is a toast for you. We have already created two toasts in our application when we press true or false. Toast also automatically disappear after a timeout. We usually instantiate a toast object with one of the makeText method. Let us look at that in more detail. Here is a sample code given. I am creating a makeText which takes three parameters. One is the context, another is the text, and the third is the duration, and then we do the show. We can directly call the makeText from the class because makeText is a static method by providing correct parameters. So you can instantiate the toast object with one of the makeText methods. There are also other definitions of makeText available and you can read about them using the following link. By default, your toast will be near the bottom. If you don't want it near the bottom, then you can use the set gravity method to set its position. This is all for today. We have discussed all the UI elements that we have used in our application. My advice for you is to now go back to the application and while running these slides, look at each application component. This will allow you to understand better. For this lecture, I have mainly been using the material available at the Android website. And I also used the book called Big Nerd Ranch Guide. And previously for Java, I have been using the book called Core Java Volume 1 Fundamentals by K.S. Forsman. All these books are easily available on Amazon.com. Thank you.